ISIS metric. In this video, I'm going to talk about how ISIS calculate metric for a pass, how ISIS calculate metric for one interface, how we can configure the metric or metric style. This is one of the important videos for understanding the function of the ISIS, because in every show, for example, show IP root or other shows, show ISIS database, you will see the metric. You should know, you should understand the metric calculation procedure in the ISIS. The first things that I'm going to talk about that is that ISIS metrics are assigned to individual interface. Look at this scenario. In this scenario, we have R1, R2, R3, and R4, 4 ISS in this scenario. And here, as you can see, R1 connected to R2 and also R2 connected to R4. In ISIS, the metric calculation is based on the total pass metric, or for example, the metric of all interfaces in pass. In R1, for example, we have ETH00. The default metric for this ETH00 is a value, for example, 10. In Cisco, we are using 10. And also the default metric for the ETH01 of the router 2 is 10. This means that for reaching to router 4, we have the metric 20 from this pass and also other 20 from this pass. Also, we have loopback 0. If you configured loopback 0 with the passive interface command, the passive interfaces metric is 0. Because of that, the total metric to reaching to the loopback 0 is 20. But if you configure the loopback 0 with the IP router ISIS command, this means that we have again here 110 metric command and 110 metric value, and this means that for reaching to the quad 3/32, we need to pass from the 3 links, and this means that we have the metric of 30. Let me to talk about the detail of metric calculation in ISIS. First, we should know the history of the metric in the ISIS. As I mentioned before, ISIS metrics are assigned to individual interface or links. The original ISIS specification, the RFC 1195, defines 4 types of metrics, as you can see here. In the original ISIS specification, we had 4 types of metric for ISIS. The first is default. Default means a value as a default value. Now in the, for example, current implementation of the ISIS, we are using only the default default metric. Look at here. For example, we says that the default metric for all of the interfaces of a router is a value 10, for example. This is the default metric. We can change it, we can configure it, but here we have a default metric. In ISIS, every interface, okay, by default has a default metric, and Cisco supports this default metric. We are using it, and I will show you how you can change the default metric from the default value of 10. Okay, this is the default metric, and this is required to be supported by all ISIS implementations such as Cisco or other vendors. Usually, we are configuring this default metric related to the bandwidth of the link. For example, higher bandwidth means a lower metric, okay? I will show you, don't worry about that. But the first thing that you should know is that in the original ISIS specification, in the first RFC, we had 4 types of metric for ISIS. The first is default, and now in these days also we are using the default metric. I will talk about that. But also we had 3 other types of metrics. The first is delay. Delay metric relates to the transit delay on the link. For example, we can configure delay metric. This means that we can define the delay of the interfaces, and according to the delay, R1 can find the best path to reaching to the, for example, networks in the ISIS scenario or ISIS enterprise. Okay, but in these days, delay doesn't for example, supported in the Cisco implementation. And after that, we had another type of metric in ISIS, expense. Expense relates to the money, okay? Relates to the monetary cost of carrying data through the link. For example, maybe you can calculate the cost of this link about the money and also this link, and finally you can configure the monetary delay, and finally ISIS can choose the best path about the money, about the lowest money, okay? And you know that in today's implementation of the ISIS, for example, Cisco, we don't have this option. And also another metric type is the error. In the original ISIS, we had error. What is the error? This is relates to the residual bit error rate of the link. For example, here we have some rate of the error, and here also we have another rate of error. We can configure this error bitrate according to the original ISIS for calculating the best path. For example, you can configure here the error bitrate, or maybe R1 can calculate the error bitrate, and finally R1 can use this error bitrate to finding the best path. Don't forget, the important and the interesting things is that each of these metrics means default, delay, expense, and also error. Each of these metrics is intended to be evaluated independently in the SPF calculation. What does this mean? This means that finally, after using this 4 type of metric, we can have 4 best metric paths according to default value, according to delay, according to expense or error, okay? Each of these metrics is intended to be evaluated independently in the SPF calculation, effectively resulting in 4 independent shortest paths first, and thus routing tables. Okay, each one computed according to a particular metric. Most ISIS implementation today, such as Cisco, support only the default metric. Let me first showing you the default metric. After that, we can talk about other details. But until now, you learned that in original ISIS implementation, we had 4 types of metric: default metric, delay metric, expense metric, and also error metric. But today's only the in the implementation of the ISIS in most vendors, for example Cisco, we have the default metric. In some cases you can, or in some iOS version, you can configure these values, for example delay, expense, and error, but these are assumed not supported, okay, and because of that we don't use them. Let me first configuring this scenario. After configuration of this scenario, we will learn more detail about the, for example, default metric, and also more detail about how we can change the default metric, for example, from the narrow metric, I will talk about that, and to the wide metric, what is the difference between the narrow default metric and wide default metric. Let me to configure this scenario starting from the router 1. This is the router 1. We need first configure the IP addressing. Then we can start with the enable command, then conft. After that, the hostname configuration. Hostname is R1. Now we have 2 interface or 3 interface here. Interface ETH00 with the IP address, okay, 10.121. You can use Notepad for example, faster configuration, and also for easier viewing about the configuration, about the detail of configuration. And after that, the IP address configuration. After the IP address configuration, we should enable the interface. No shutdown. Then we need to 2 other interface. The interface ETH01. This interface has IP address of 10.131/24.255.255.255.0. Okay, and after that interface loopback 0. This is the interface loopback 0 with the IP address of quad 1 quad 255. Okay, we don't need no shutdown because you know that the loopback interface by default is enabled. And after that, we need to configure ISIS in this router. This is one of the level 1 routers. Let me to use router ISIS. Then we should configure the net address 49.0.0.1 for example, quad 0, quad 0, 0, 0, 1, then